Here we are for the third page of the review for exponential functions. And I wasn't sure where I wanted to place myself up there, so we're going to see if that makes sense to me in the end. We'll see. All right. So when in problem 6 here, we're asked to find the equation of that function. The first thing I notice is that my asymptote here is at y equals 0. So my k value is going to be 0. The next thing I notice is that my intercept, my y-intercept here, well, it certainly appears that, let's zoom in a little bit, certainly appears we're going by twos here. So that looks like it's going to be 0, 5. And if I move to the right 1 unit, um, hard to tell what that value is. I would say I'm going to guess that it is 110 and that this is 220. If it's not, then it's kind of hard to be able to say what else. It'd be hard to tell what the equation is. So here we have y is equal to, well, we have the initial value of 5. And we can do this, we can say that that initial value is the y-intercept here because our k, our asymptote, is at y equals 0. Our k is 0. Our multiplier here, we can see, is 2. We're multiplying by 2. And so it's y equals 5 to the 2x. And that is the problem number 6 there. Here, a problem about the New York Mets. Yay, Mets are my favorite team, and I didn't even write this. A Nolan Ryan baseball card in poor condition sold in 1975 for $248. In 1985, it sold again for $460. Assuming that the growth in value is exponential, what was the rate of appreciation on this baseball card? All right, so thinking about the general form of these kinds of problems, we have y is equal to a times 1 plus the percent raised to the x power. So x is the number of years, y is the amount that it's worth after some amount of time, a is the initial value. So we can set up this equation then. We can set up the equation 460 is equal to 248 times 1 plus some percent. I'm going to use p for my percent there. And raised to the x power. Now the way we're going to get x there is we're going to take the 1985 and subtract 1975. And so we'll do 1980. Just realized I'm going to bump into myself there. 1985 minus 1975, and we get 10. So it's going to be to the 10th power because it's 10 years of the appreciation. All right, so the first thing we're going to do here is we are going to divide by 248. And when we do that, let's see what we get. I'll bring the screen over so you can see it there. Just a moment. So I'm going to do 460 divided by 248, and I'll get about 1.85. So this is an estimate of 1.85. So I'm going to use approximate there. And that's going to be 1 plus p to the 10th power. Now, in order to undo that 10th power, we're going to need to use the inverse operation of exponents, which are roots. So we're going to take the 10th root on each side there. And when we do that, so on our calculator, we have to find that 10th power, or 10th root, excuse me. So, whoops. So it's going to be the 10th root, of 1.85, which is the answer. So I don't want to use the 1.85. I want to use the exact value there in my calculator. And so what I get is I get 1.06 approximately, so I'm still using those estimates. 1.06 is equal to 1 plus p. Now, if I subtract 1 from both sides, I will get 0.06 is approximately equal to p. And if I want to give a little better estimate, I can convert that decimal into a percent of approximately 6.4%. And the reason why I would do 6.4 is because it's this 3 right here will be rounded to a 4 due to this 7 right there. So 6.4% is a good estimate on that. What's the equation of the fine-looking exponential function at right? All right, so what do we know about this function? Well, it's not going down like this or like that. That tells us something pretty important. And it means that the a value is going to be negative. And here we have a -1 there. And our asymptote looks like it's going to be at y equals 2. So I'm going to put in my asymptote here at y equals 2. That tells me my k value, and that's going to be the easiest place to start, is from the k value there. So y is equal to a times b to the x, and then we can say plus 2. And now, from our asymptote there, if we go down 1, 2, 3, we get this point right there. So that means that my a value is going to be -3. So let me show that on here. Whoops. Because I go down 1, 2, 3, that means my a value is -3. So I have y equals -3. And now I know that it's times b to the x plus 2. The next thing is my multiplier. Okay, so I can see also, whoops, I can see that, again, this distance is 3, and this distance is 6. So I'm reducing the distance as I move to the right. I'm reducing the distance from the point to the asymptote by half. So that means that my b value is going to be 0.5. So let me see if I can annotate this in a way that makes sense. So multiplying by 1/2 or 0.5. So now I have y is equal to -3 times 1/2 to the x plus 2. And a good way to test that out is just to pull up a Desmos graphing calculator and check it out. And I'll do that right now. Bring it over into the screen so you can see what I'm saying. So if I do y equals -3 times 1/2 to the x power plus 2. And let's see, this point right here is -1, -4. So that's good. And this is 0, 1. Oh, 0, -1. Yep, that's right. 0, -1. And then let's see, it looks like 2, 1.25. Let's see right here. 2, yep, 2, 1.25 does look like it's right there. Awesome. So we've just checked using our Desmos technology to see that we did that problem correctly. So that is the third page, and we'll have one more video for page 4 on this review.